Let's get right into Math Basics, Lesson 10, covering velocity. Question number 1. A channel 12 feet wide has water flowing through at a depth of 4.2 feet and a velocity of 3.2 feet per second. Find the flow rate through the channel in cubic feet per second. Well, let's look at flow rate in cubic feet per second. So here in my ABC formula conversion tables, we have flow rate in cubic feet per second equals the area in square feet multiplied by the velocity in feet per second. So what we need to do is, we'll write down that formula. Flow rate in cubic feet per second equals area in square feet multiplied by the velocity in feet per second. First thing I need to do is figure out what's the area. Well, I know area is equal to, and in this case, we're going to go with width. Channel is 12 feet wide. 12 feet over 1. And then we have a depth of 4.2 feet. So here I have, and by the way, that area is in square feet. We have one here, we have one here. The units of measure match up. So let's solve. 12 feet times 4.2. That gives me 50.4 square feet. So let's get back to this formula here. We're going to rewrite it with all the best information that we have. Flow rate in cubic feet per second equals area, which is 50.4 feet squared over 1. And then the velocity, we're going to multiply it by the velocity. And the velocity is 3.2 feet per second. Now let's see what that does for us. We have square feet and feet. 2 plus 1 is 3. So we have cubic feet. And then here we have 1 times second equals seconds. So we're in good shape. Let's multiply that across and see what we get. $50.4 times 3.2. That equals 161.28 cubic feet per second. Our best answer is A, 161 cubic feet per second. Question number 2. The velocity through a channel is 2.1 feet per second. If the channel is 6.5 feet wide and 2.8 feet in water depth, what is the flow in cubic feet per second? So we want the flow in cubic feet per second. So our formula is flow rate cubic feet per second equals the area in square feet multiplied by the velocity, and that's going to be in feet per second. So we don't have the area. We're going to have to calculate out the area. The area is going to equal and in this case we have width (6.5 feet over 1). We have 2.8 feet in depth. Just going to write it down right there because I forgot to write it down. Again, I make mistakes, but I don't want to miss anything. So I'm going to leave this in the answer key that you can purchase in the downloads. The depth is 2.8 feet. I have a foot here, that's square feet. So let's see what I get here. I have 1, 2 square feet. Let's multiply that out. 6.5 times 2.8, that's going to give me 18.2 square feet. So let's get back to our formula. Flow rate in cubic feet per second equals the area, which now we know is 18.2 square feet over 1. We're going to multiply that by the velocity, and the velocity through the channel is 2.1 feet per second. Let's make sure that adds up. I need cubic feet. I have 2 here, 1 here. That equals cubic foot. 2 plus 1 is 3 cubic foot. I have 1 multiplied by second. That gives me seconds. And that's what I'm looking for. I'm looking for cubic feet per second. So we'll multiply that out. 18.2 multiplied by 2.1 gives us 38.22 cubic feet per second. The answer is D. Question number 3. Water is flowing through a channel 6 feet wide and 3 feet deep. If the flow is 28 cubic feet per second, what is the velocity of the water? Should say, what is the velocity of water in feet per second. I can see through the choices here, they want it in feet per second. So we want the velocity. We want the velocity, and we want it in feet per second. So let's look at our ABC formula conversion table, the math formula sheet. Look at that, I turned right to it. Velocity. The velocity in feet per second. Now there's two of them to choose from. One is flow rate in cubic feet per second over the area, or divided by the area. The other one is distance divided by time. That's my chupacabra. He's okay. He's always getting underfoot, and he makes that crazy ass sound. So getting back to the formula, cubic feet over area, distance over time. This is giving us the flow in cubic feet per second. In that case, we want this formula, velocity, flow rate divided by area. I'll just show it to you one more time just so you can see it. This is the formula we're looking for. So let's write it down. Velocity, feet per second, equals flow rate in cubic foot per second divided by the area in square feet. Okay, so we need all our units of measure to match up. So this question does not give me the area. However, it gives me the width and the depth. So let's calculate out the area. The area is going to be in square feet. It's giving me the width, which is 6 feet, and it's giving me depth, which is 3 feet. I have feet, which gives me square feet. So let's multiply that out. 6 times 3. 18 square feet. So now I know 18 square feet is going to be in the area portion of this formula. So let's rewrite our formula with all the correct variables. Velocity in feet per second equals flow rate. See if I can write legibly here. Flow rate. The flow rate is 28 cubic feet per second. 28 cubic feet per second. We're going to divide that by the area, which is 18 square feet over 1. So I need to take these units of measure to feet per second. We have this dividing line here. We also have these dividing lines. Cubic feet minus square feet leaves us with foot. Second times 1 leaves us with second. Looks like I have a good formula here. It's going to work. I'm going to calculate it out by taking 28 and dividing that by 18, and that's going to give me 1.56 feet feet per second. The correct answer is, and which is the closest answer, is D. Question number 4. Water is flowing through a channel 4 feet wide and 1.5 feet deep. If the flow is 10.5 cubic feet per second, what is the velocity of the water? Well, we want to know what the velocity is. And the velocity is going to be in feet per second. So we'll write down our formula, which we've already looked up. Velocity in feet per second equals the flow rate, which is in cubic feet per second, and the area, which is in square feet. Now again, they didn't give us the area. We need to take the width and the depth to calculate out the square footage, their area. So we will write area in square feet equals the width of 4 feet over 1 multiplied by the depth, 1.5 feet over 1. We're getting, get the wrong one. We want square footage. We have feet here and feet here. That's going to give us square feet. So let's multiply that out. 4 feet times 1.5, that's going to give us 6 square feet. Perfect. So let's rewrite out our formula with all the right variables here. So we want velocity in feet per second equals the flow rate. It's going to be cubic feet, 10.5 cubic feet per second. We're going to divide that by the area, which is 6 feet, 6 square feet. Now let's do some cross canceling, make sure we have everything we need. We have the dividing line, we have this dividing line, and we have this dividing line, vert. Cubic feet minus or cancel out square feet is going to give us foot. Second multiplied by 1 is going to give us second. That's what our answer is going to be in. So let's multiply that out, or let's divide. Divide 10.5 by, 10.5 divided by 6. And that's going to give us 1.75 feet per second. The best answer is A. Question number 5. A 6-inch diameter water main needs to be flushed with a water velocity of 5 feet per second. What should be the flow through the main in gallons per minute? So we're looking for flow in gallons per minute. Now I'm not going to look on the math formula sheet because it doesn't have a formula that says flow in gallons per minute. It just isn't there. Flow, cubic feet per second. Let's look at velocity. feet per second. So we're going to have to figure out this formula here. What formula are we going to use? We are looking for flow in gallons per minute. Gallons per minute. So this is when it comes in handy to understand these conversion factors that we have right here listed on this desk. What we have is velocity. So I'm going to write down velocity, and that's going to be in feet per second. Now, I'm also going to write down, here we have velocity, and it's in feet per second. I also have a 6-inch diameter water main. 6 inches in diameter. I'm going to go ahead and I'm going to suppose that I need to get to gallons per minute. And to do that, I need to calculate the gallons that are available in this 6-inch diameter water main. Well, I know there are 7.48 gallons per cubic foot. I also know that somehow I need to convert seconds to minutes. Remember, my units of measure have to match. So I think what I'm going to need to do, and because I have a 6-inch diameter water main traveling at a velocity of 5 feet per second, it looks like I'm going to have to calculate out the area. So I'm going to multiply this times area, and I'll show you why. Now remember, there are 7.48 gallons per cubic foot. I already have a foot here. I have 2 of them here. So if and remember, look at that division line. Cubic foot is below the division line while these 2 are above the division line. So I'm going to go ahead and multiply by 7.48 gallons per cubic foot. And that's going to allow me to eliminate this foot, these 2, and now I'm left with gallons and seconds. But seconds does not match up to minutes. So I'm going to add 60 minutes, or 60, excuse me. That is 60 seconds per minute. And again, that's because I have seconds here and I need to convert it to minutes. So seconds and seconds will cross cancel out. Cross cancel out seconds here, seconds here. I am left with gallons per minute. Sometimes it's like this on a certification exam, and I don't want you to be surprised by that. If you understand these conversions, it's going to help you in these situations. All right, so let's go ahead and rewrite this formula. Flow in gallons per minute. And I'll re-explain this. We have velocity, and that is in 5 feet per second. 5 feet per second. Now again, I want to calculate out the area, because area is in square feet. I'm going to write it right here over 1. Now, at this point, I need to figure it out. So let's get area. We'll just do it right here. Area in square feet equals, now this is a 6-inch diameter water main that needs to be flushed. 6-inch. So we know we're going to have to use 0.785. We know this from previous assignments. But I need it in square feet, and this is in inches. Those units of measure don't match. I need to make them match. How am I going to make them match? Well, I have 6 inches over 1. I'm going to divide that by 12 inches per foot. 6 divided by 12 gives me 0.5. That is 0.5 feet. How do I know it's feet? Well, I cross cancel this inch and this inch. I'm left with feet. That gives me feet. So now I know the 6-inch diameter is a 0.5 foot diameter water main. So I'm going to multiply that by diameter, which is 0.5 feet over 1. Multiply it by the diameter again, just like we did in previous assignments. 0.5 feet over 1. I have feet. It's going to give me square feet. So let's solve for area. 0.785 multiplied by 0.5 by 0.5 again. The area is 0.196. Let's just call it 2. 0.2 square feet. So let's write that 0.2 square feet. Now we need to multiply this by, right here, 7.48 gallons per cubic foot and 60 seconds per minute. Let's cross cancel. I have 1 foot here, square footage here, so that's 1, 2, 3, and I have cubic foot here. So I can cross cancel these and get rid of all the foot units of measure. I have seconds here, and that gives me minutes. So I'm left with gallon and minute, which is the unit of measure I'm looking for. So let's solve. 5 multiplied by 0.2 times 7.48 times 60. And that's going to give me 448.8 gallons per minute. What's the best answer? Certainly, it's B. Very good. All right, question number 6. An 18-inch diameter water main is to be flushed at a velocity of 4 feet per second. What should be the reading on the flow meter in gallons per minute? Well, it's the flow meter, and it's in gallons per minute. So this question is going to be just like the last one. We're going to have to figure it out. We want flow in gallons per minute. We have the velocity 4 feet per second. Look at these units of measure. Gallons, minutes. I know I'm going to have to multiply 60 seconds per minute to remove that second and convert it to minutes. But before I do that, I have a foot here and I've got 18-inch diameter water main. I've got to convert that to cubic feet. So let's go ahead. We're going to get the area of that 18-inch diameter water main. So let's find the area in square feet equals, and this is 18 inches in diameter, so I'm going to multiply that. I'm going to start with 0.785. We know this from previous assignments. This is how we calculate the area of a round of a circle. And we'll need the diameter in feet over 1, and we're going to multiply that by the diameter again in feet over 1. So the diameter has to be in feet. Again, we're looking for feet. We're looking for square feet. So to get square feet, I need to convert an 18-inch diameter to feet. I'll do that by writing 18-inch over foot, or excuse me, over 1, 18-inch over 1, divided by 12-inch per foot. This is a true statement. There's 12 inches in a foot. Now, I know this is going to be correct because I can cross cancel out this inch and this inch. I'm left with feet, which is the unit of measure I'm looking for. So if I take 18 divided by 12, that's going to give me 1.5 feet. So let's put that in to the equation. Area in square feet equals 0.785 times the diameter of 1.5 feet over 1. Multiply that by the diameter again. 1.5 feet over 1. I have a foot here. I have a foot here. It's going to give me square feet. So we'll solve. 0.785 times 1.5 times 1.5. That's going to give me 1.7. I'm going to round up to 7 square feet. So let's write that down right here. Area 1.77 feet squared over 1. So now we have foot, square foot. We have this conversion factor, 7.48 gallons per cubic foot. This helps me out a lot because because cubic foot is below the division line, I can eliminate this foot and this foot. I'm doing that because there is no footage unit of measure in the answer. It's in gallons per minute. So I'm eliminating the footage, but I also need gallons. So that 7.48 gallons per cubic foot is helping me in a couple of ways. Eliminate this foot, eliminate that foot, cross cancel out here. But it also leaves in gallons. Now I need to convert seconds to minutes, so 60 seconds per minute. Now I can cross cancel out the seconds and I'm left with minutes. So let's go ahead and rewrite this right here so it's all nice and fresh. Flow in gallons per minute equals velocity, which is 4 feet per second, multiplied by the area, which is 1.77 square feet over 1. Multiply that by a conversion factor, 7.48 gallons per cubic foot, and we're going to multiply that by 60 seconds per minute. Let's cross cancel. Let's cross cancel and get down to where we need to be in these units of measure here. There's a foot, it's one of them. There's two of them, that's 3. So I cross cancel out cubic feet. I have seconds here and seconds here. Cross cancel. One's above the division line, the other's below the division line. I'm left with gallons and minute, because minute times 1 is minute. So I have the correct unit of measure. I'll multiply this across and solve. It's going to be 4 multiplied by 1.77 times 7.48 times 60, and that's going to give me, oh boy, this is a big number, it's kind of scary, 3,177.5 gallons per minute. Let's see if that adds up. Look at that, the correct answer, which is the closest answer, is 3,170 gallons per minute. Please like my video. This helps me. This is another source of revenue for me. I work for a water wastewater utility. I run field operations, and I make good money. But if you like this video, if you subscribe to my channel, if you leave a comment, positive, negative, it doesn't matter. You can ask questions and I will try to get to them in a timely manner. I would appreciate it. It helps my YouTube channel. If you follow the link from below the video to my webpage, you can download all my assignments with the answer keys. There's also free links to the ABC math formula sheets and conversion tables for water, treatment, and distribution, and a second math formula sheet or formula conversion table for wastewater treatment and collection. You want the 2017 US Canada version, which the link will take you directly there. I'm closing in on the end of this series. There's just a few more videos to go. Look forward to more videos coming soon. Thank you.